Have you ever wondered why your model's accuracy drops when you switch from training to validation? It's a common concern among data scientists and machine learning enthusiasts. Today, we're diving into the reasons behind disabling dropout during validation and testing. I totally get it. You trained your model with dropout and achieved an impressive 80% accuracy. But then, during validation, you forgot to set the probability to 1, and suddenly, your accuracy plummeted to 70%. That's a significant drop, and it can be really frustrating. So let's break down your question. Why should dropout be disabled during validation and testing? This is a crucial aspect of model evaluation that many overlook. If you've ever faced a similar situation, you're not alone. Let's explore this together. To understand this, we need to look at what dropout does. During training, dropout randomly disables a fraction of neurons to prevent overfitting. However, during validation and testing, we want to use the full capacity of our model to get an accurate assessment of its performance. Stay with me, because by the end of this video, you'll not only understand why dropout should be disabled during validation, but also how to implement this correctly in your models. To understand why dropout should be disabled during validation and testing, let's first clarify what dropout does. Dropout is a regularization technique used during training to prevent overfitting by randomly setting a fraction of the input units to 0. When the user trains a model with dropout, it helps the model generalize better. However, during validation and testing, the model needs to use all its learned features to make accurate predictions. This is why dropout should be turned off. Now, regarding the user's experience with accuracy dropping from 80% to 70%, this is indeed a significant change. When dropout is active during validation, the model's performance can be adversely affected because it is not utilizing all its capabilities. To fix this issue, the user should ensure that the dropout probability is set to 1 during validation and testing. This means that all neurons are active, allowing the model to perform optimally. In summary, the user should disable dropout during validation and testing to ensure the model uses all its learned features. This will help maintain high accuracy and provide a better evaluation of the model's performance. Fun fact, the concept of dropout was introduced in a paper by Geoffrey Hinton in 2014, and it has since become a standard technique in deep learning. It's amazing how one simple technique can have such a big impact. Now, let's look at the answers provided by other users. One user explains that the main reason to disable dropout during validation and testing is to utilize the full capability of all learned neurons. When making predictions, you want to ensure that no neurons are randomly skipped, which is why the dropout probability is set to 1 during these stages. That's all on that answer. Let's take a look at another one. One alternative approach is called Monte Carlo dropout. In this technique, dropout is not disabled during testing. Instead, the model runs multiple times with the same dropout rate. This allows for the calculation of the mean and variance of the results, which helps to determine uncertainty in the model's predictions. For more information, you can check out Uber's application of this technique, which quantifies uncertainty in neural networks. That's all for that response. Let's see what someone else had to say. This user explains that dropout is used during training to reduce overfitting by acting as a regularization parameter. They emphasize that if your model shows high variance, meaning a significant difference between training and validation accuracy, you should apply dropout only during training. This is because during validation and testing, you need to ensure all neurons are active to accurately assess the model's performance. Here's a pro tip. Always double-check your model settings before validation. A small oversight can lead to significant drops in accuracy, just like what you experienced. Taking a moment to verify can save you a lot of headaches. And there you have it. By disabling dropout during validation and ensuring your model is in evaluation mode, you can achieve more reliable accuracy results. If you found this video helpful, don't forget to subscribe for more insights and tips on improving your machine learning models.